All right, the next system we're going to show here is the VacuSeal vent-secured roofing system. This was shown during the presentations yesterday, I believe by David French or Chad Berman. It was also featured at the product fair last night, and you guys had a lot of questions about it. So we're going to show you on a larger scale today how it's installed and tell you a little bit more about the system. Overall, the system relies on negative pressure that's created through this vent here and the wind on top of the roof to create negative pressure to hold everything in place. So overall, the system is a completely loose laid system, and it's ballasted by the wind or these vents. These vents are one-way vents, and it relies on the Venturi principle to create that negative pressure. So as wind is blowing on the roof, it's passing through this vent, through the two different spheres here. And it's actually, the wind is accelerating through this, through the two spheres. That's the Venturi principle, and it works. Underneath here, you can see the second half of the bottom sphere is hollowed out. And through the three channels where I'm holding it, that's actually where the one-way vents are located. So there's flaps in there that allow for only one-way air movement through this vent. So as air is moving on top of the roof and as air is getting sucked out from underneath the membrane through this one-way vent, that's what creates that negative pressure to hold everything in place. Again, everything is completely loose laid. It's all relying on the wind and creating negative pressure through this vent to hold everything down. Now, some great applications for this system is really new construction, solid concrete decks. Because the reason why we like it for this application is because the main priority here is in how the system operates is that we want a complete air seal at the deck level. So a solid concrete deck allows for that complete air seal. Other applications would be an already existing built-up roof or a fully adhered roof that you're going over, so a retrofit application or a re-roof application. So you can go directly over those existing systems, especially if they already create an air seal at the deck level, with mainly just the insulation that would be specified in the cover board, all loose laid, as well as the membrane, and then install these vents. Now, these vents aren't just installed all over the roof. They're typically found about 20 feet inward from the perimeter, and they're spaced about 20 feet apart from each other as well. It's an overall engineered system, so we're not just going to place these anywhere on the roof. The first step in the process of evaluating any roof system to see if VacuSeal is a fit is to do an engineered layout for these vents. And it's really to maximize the negative pressure that's going to be on top of this roof to hold everything in place. So again, the first step is to do an engineered layout through Carlisle. And what we do is we give an actual layout or roof design that shows the placement of all these vents. Again, they're typically about 20 feet apart from each other, as well as 20 feet inward from the perimeter. So if a large big box retailers or a distribution center, there may be some additional vents inward in the field, but mainly what you're going to find is that we need to create negative pressure around the perimeter to hold everything in place. So again, the first step in any roof system would be the insulation, so that would be underneath this cover board. And the reason why we have this cover board here shown after Brandon talked about EcoStorm is because we require a half-inch cover board on top of all these systems. Whether that be a re-roof or retrofit application, we're still going to have a separation or cover board in all of our systems. The reason why we require either a gypsum board or our EcoStorm board is because we want the weight of those boards to hold the insulation in place, as well as create a little bit of a gap in between the membrane and the board itself to allow for air movement underneath the membrane. The reason why we show EcoStorm here, and it's the latest advancement within this system, is allowing EcoStorm to be installed, is because it can take on a little bit moisture. It's more moisture resistant than if gyp boards take on moisture and it just crumbles. So we like utilizing EcoStorm with this system because if you're going over like a built-up roof that might have some moisture captured in that roofing system, EcoStorm is the perfect fit because it can take on that moisture and it's really moisture resistant. Then on top of the cover board, where you're going to install are what's called air distribution strips. And these guys are going to come out here and install these strips here. This is all going to be a part of the engineered layout and the drawing that you would receive from us. Typical fashion of installation of these air distribution strips is exactly what these guys are going to show. So imagine where Jesse is sitting right there. That would be the roof edge, and you're going to have 3 distribution strips leading to a point. And again, this is all pre-engineered and laid out. Those air distribution strips allow for air movement underneath the membrane. So it really just assists to make sure the air is moving from the perimeter of the roof to the vent itself to allow it to create negative pressure. Again, the typical fashion here is that there would be 3 strips coming together at the point. You can see that Jesse's also placing plates on each of the edges here. That's one trick that contractors typically use during installation to hold the air distribution strips in place during installation. There's no really installation technique here. We typically recommend contractors to use plates and fasteners to hold the distribution strips in place. You could also tack it down with a little bit of adhesive, but this is typically the easiest way to do that. And you're not screwing down to the deck level. You're really just making sure it's tacked down so it's not moving during installation. If there was to be another vent that's going to be installed where I'm standing here, these air distribution strips would actually be connected. So the next air distribution strip would overlap with that one right there. That's connecting all the vents to each other and compensating for each other. If one were to be damaged or if one was not creating enough negative pressure, another one would compensate and create enough negative pressure to hold everything in place. You can see also that they ran the strips a little bit past where the vent will be located, and that's because these typically run about 3 to 5 feet as well past the vent themselves to make sure that air is flowing directly to the vent to make sure that this vent can suck the air out from underneath the membrane. So next, the guys are going to kick out the membrane here. And as you kick out the membrane, be careful to know where the air distribution strips come together. Again, that's where the vent's going to be located. So as you kick out the membrane, the contractor would mark the location of where that vent would be located. Again, another trick and reason why we recommend plates and fasteners is, as you saw, Ryan was feeling around there for the plates. That already indicates where the center of that vent should be located. So it's another trick for contractors to know where the vent should be located. Then at that location, you're going to cut a 10-inch wide diameter hole, which matches to the bottom half of the sphere of this vent itself. Again, you're allowing for air movement underneath the membrane that leads to this vent so it exits this vent and creates negative pressure. You can't really see here as I'm holding it, but I encourage you guys to come up and see. But the bottom sphere, the bottom part of the sphere, or the top sphere, actually has holes in it, and that's where the air exits from this vent. So again, it's moving through the bottom sphere, through these 3 channels where I'm holding it. That's the one-way vent, and then it comes out through the top sphere. At the same time, again, air is passing through, and that's what creates the negative pressure. What Ryan is holding now is how we actually sell the vents. We do not sell the vents like this. They actually already have pre-applied skirts to them, and it's compatible with EPDM, TPO, and PVC membrane. It's a 30-inch wide pre-applied skirt. So this is great for contractors so they don't have to field fabricate anything. They already has the pre-applied skirt, and they can flash this into the field membrane. It's definitely a great advantage here. So as Ryan places that there, we're not going to flash it in. But again, depending on the membrane type in the skirt for the vent itself, you would just flash that in according to standard procedures here. Overall, this system isn't really new technology for us. We worked with vented technologies or wind ballistic technologies for several years now, and really as a test market. So we have about 8 million square feet of this already installed. So while it is new technology or kind of different technology away from mechanical fasteners and adhesives, the first patents on this date back to the early 1970s. So the concept of using one-way vents and the wind to hold everything in place is not necessarily anything new. But it's something that we're finding a great deal of applications for in the field that contractors utilize the system. Again, concrete decks is a great example, retrofit applications, as well as there's no VOCs and no odors, so occupied buildings, and no cold weather limitations here with this system because you're not using adhesive. So great advantages. And the last one I'll leave you with is if you don't want to disturb any of the existing roof. Again, if it's a built-up roof, maybe there's asbestos in that roofing system that you just don't want to disturb. This is, again, a great example of you can just go directly over that system. A lot of times, if no insulation is necessary, just directly over with a cover board and the membrane itself, and you're done. So it's a great labor savings for the contractor, and it's fairly easy to install after the engineering is already completed by Carlisle. Any questions? So he asked the question if you're going over an existing roof, if it's an EPDM roof, I believe you said, does the existing have to be mechanically fastened or adhered, or what does the existing have to be? Is that correct? So if it's an already fully adhered system, you're already at a great advantage because you're already having a complete air seal at the deck level. So that would just require an inspection to make sure that a complete air seal is already still existing. If not, then you have to fix those areas to make sure there is a complete air seal. And it's the same with mechanically fastened system. You just want to make sure that there's a complete air seal at the deck level. So typically achieved if it's not by the deck itself, by different air and vapor barrier products. So each project is going to be dependent on what the existing is, but there's really no limitations if there is an existing that we couldn't go over it, maybe with some modifications. Yeah, so he asked the question, if you're doing a re-roof and you need to add more insulation for code requirements, is that acceptable? The answer is yes. So I kind of gave the best case scenario. If you don't need more insulation or R value, you could directly go over with a cover board. But if more insulation is required, then yeah, you just put the insulation and the cover board on top. Again, the cover board has enough weight to hold everything in place, and you go on with the system. Yeah, so John was asking, can you just go over the cover board requirements again? So our requirement would be a 1/2-inch gypsum cover board, so Securock Densdeck Prime, or our EcoStorm board. Again, we're pushing people a little bit towards EcoStorm, especially for built-up applications because it is moisture resistant. But any of those cover board options, so it cannot be any standard HD boards. It has to be a gypsum board or an EcoStorm board. Good. He asked the question, is the new membrane adhered? And the answer is no. So everything is completely loose laid. So again, if you were doing like a stone ballast, a typical stone or paver ballasted system, this is exactly the same. So think of it as, instead of using pavers or stone, you would have these vents in place to ballast everything in place by negative pressure. So everything is loose laid, insulation, cover board, and membrane. Yeah, so I'm guessing he's asking if the existing system is already a ballasted roof, correct? Yep, so if the existing system that you want to go over is already a ballasted roof, all that we would require is the removal of that stone ballast. Many times it's just the removal of that membrane as well. So we would remove the ballast, remove the membrane, and then you would just go over with the system. Again, all dependent on making sure that there's a complete air seal at the deck level, but all you would have to do is remove that stone ballast and go over with this type of system. I'm sorry, what? So he's asking, do you have to remove just the ballast or ballast and the membrane? And it's really just, again, project dependent. Most of the time we would recommend removing the membrane and the stone ballast if the membrane is at least reached its lifespan or there's any damage or breach in that membrane. That's typically why we would want to replace that. But it would all just depend on the project and obviously the condition of the existing membrane. Yeah, so John's asking, well, how does this play with incorporation of other walkway pads or pavers or other type of amenity space here? It's all fair game. I mean, all that stuff, typical walkway pads is acceptable. If you're adding any pavers or roof garden systems, that would act as ballast essentially for the system as well. So it's already held down by these vents, obviously creating negative pressure. But if you're adding concrete pavers or something, that also would just be acting as additional ballast for the overall system. Yeah, so the question is, if pavers are added after the fact, what would be any considerations or enhancements we'd have to do? It's with anything that we would like you to consult with Carlisle to understand what our requirements would be if you're adding any overburden components. We have our own standard details. We typically for like a roof garden system needs to be a fully adhered system underneath, so that wouldn't necessarily be applicable. But if you're adding pavers over top, there would be certain requirements. So it just depends on if you're looking to install the pavers directly on the membrane or over like a slip sheet of membrane or protection fabric. If you're doing like a pedestal system, again, just consult with us because there would be certain requirements if we would be installing third-party or overburden components. Yeah, so his question is mainly the concern of air movement to the vent itself. Again, as long as you're consulting with us with any deviations from the original layout that we would be looking for the system, we would be able to consult with you to understand what if any modifications are needed. So if you're putting pavers up directly to the vent, there might be some things that we have to change, either with the vent layout or not allow for the pavers, but any consultation with us, we'd be able to let you know if that affects the maximum performance of negative pressure through these vents. Can you repeat that? Yeah, so he was asking, is there any additional considerations for air seals around penetrations? And the answer is yes. So we actually have a full book of details and specifications on our website, or come see me afterwards and I can send that to you. There are some modifications to some of our details, or some other additional details that we allow for. So for example, like for a curb, if you're using like a termination bar, we have an additional product, which I did not show here today with specific details, which is called our sealant tape. It's an butyl sealant tape that's used essentially in lieu of water cut-off mastic. So that creates a better seal behind a term bar than water cut-off mastic. So that's one example. The other thing is if you do use field membrane and elastoform to create that seal, and then you counter flash it as well over that, like you said, at a curb, that could be an example as well. But typically, edge details, we try to make them as standard as possible, but there are some other enhancements, so I would just encourage you to look at those details, or I can help you with that for anything project specific. Yeah, so his question was, how do you handle facilities that have like large bay doors that are open? I'm going to guess maybe like some freezer applications as well. Again, I would consult our details. There are some additional things that we would require for those penetrations, as well as creating that air seal. Again, these details are actually pretty similar to those types of applications because we do require an air seal at the deck level rather than sealing it at other penetrations or perimeters. So I would just consult with our details, and I can get you those afterwards as well. Last one here, I'm going to turn it over then. Yeah, so he's asking about code compliance reports that we have. We did testing at various wind tunnels at UL. It's certified at 195 PSF pressures as well as NASA as well. So we've done multiple different testings. We've also did a testing that we typically use to submit for different code approvals as well as at the local level. So we could share any of those engineering reports to show the uplift pressures and the negative pressures that this creates to hold everything in place. But there's various code approvals as well as testing reports that we have to meet those requirements. All right, with that, I'm going to move on and turn this over to Jesse. Thank you.